can start. I would like to welcome with us Manfred Stede, an old friend, if I may say so, of our discourse group. And we are really very happy that we could arrange this meeting. It would be certainly much better if we could meet in person. But even so, it's nice to see you here, at least on the screen. And we are very curious to hear what you have prepared to tell us. So please start.
Hey, thank you. Yeah, it's my pleasure to join you, even though only under this particular circumstance here. Let's see. So there should be slides. And better, I guess. Yeah, welcome everybody. As I said, good to see, especially the discourse group after some time. What I want to do today is two fairly separate things, actually. The first part of the talk will be a report on work we did recently over the past 3 or 4 months. It's essentially a case study in text classification, but under the heading of framing climate change, which is, as you notice, the overall title of this talk. So that will be kind of the first half. And only afterwards I will ask framing, what is framing? How do we define this? And to paint some context for our own work, I will then very briefly discuss some studies from the social sciences on framing climate change. It's a relatively important topic there. And then mention NLP work on framing, also briefly, I suppose, and then sum up, make a few comments on what we found and give a short outlook. So that's the idea. And as I said, it's not 5 bullets of the same weight, it's rather 2 big chunks. What got me started on this whole business of framing and climate change is more or less this particular paper, which appeared in 2018 by Mike Hulme, who is one of the eminent international climate researchers and a team of co-authors from, I think, also the United Kingdom. And they looked at Nature and Science editorials and wondered, how do these magazines portray or paint climate change over the years? And in particular, the editorials, not the whole magazines, but just the editorials. So we're looking at this kind of text. Here's one from Nature, somewhat more on the longer end, others are a bit shorter. And they wanted to figure out from 1966 to 2017, I believe, how did things change in terms of coverage and framing of climate change? So why these 2 journals? They are among the top scientific journals in the world, certainly. And one of their arguments is they're relevant not only for scientists, but also to the wider public, because both Nature and Science are widely cited in the public media. Knowledge is actively constructed and authorized. And we have editorials, as I said, which is for one thing nice for me, because some of you know opinionated commentary text is one of my favorite text types anyway. And these editorials are mostly written by the journal editors. In that sense, they are the voice of the journal, really. So when the editorial in Nature in 1975 says something about climate change and how dramatic or non-dramatic it is, it's kind of important. And one of the aspects of the study was to compare North America, which is Science, to Europe, which is Nature. Yeah, so they assembled overall 490 editorials from the time span that I mentioned. They used these keywords to find the texts, which generates good recall, but as you may imagine, not very good precision, because an article that mentions carbon is not necessarily a climate change article. That's why they had a fairly extensive manual filtering phase afterwards to make sure they have a solid corpus where every article really mentions climate change. And that amounts to about 6% from the internals from the 2 journals. And then the main contribution was to annotate frames. Frames in their conception are challenges, the challenge that is formed by climate change. This can be an economic challenge, a developmental challenge for other parts of the world, security challenge, an ethical moral problem, technological or energy problem, an institutional governance challenge, if you will, scientific problem, or just a communication issue. These frames they found in a mix of a bottom-up and top-down manner. They were not the first to propose such a list, as we will see later on. But they also looked at the data for quite a while and then decided that this frame set of 8 categories captures the situation well. And so they annotated the complete corpus. Let's not go through all these definitions. It's just to show you one example. How did they actually, oops, can't click on this, define their frames. So for security, for instance, climate change is a geopolitical security risk by introducing new dangers into inter and intra-state relations, or it is a threat multiplier requiring new forms of international or state-level security responses. So with these 1 or 2 sentences, they characterized all the frames and ran the annotations and then measured agreement and so on. That was all nice and well. And I'm going to mention just one outcome of that study because it's not the main point of my talk. So what they did is then track the frame usage over time, right? So from 1966, there was very little climate change, all the way to 2016. As you can imagine, it grows over time. And they correlate this with some events in the real world, like the Kyoto Protocol in 1997, the IPCC reports, the International Panel on Climate Change reports, and some other things. And they break it down into different frames. So for instance, let's look at communication in brown is virtually absent in the beginning. Well, the greenhouse effect, global warming was just being discovered. So how to communicate it was not really a big deal at the time. But then later on, it became, around the Kyoto times actually, it became more prominent and is now really a significant part of the cake here. And then they compared nature to science and did a few other studies that resulted from the data. Okay, but me being a computational linguist, of course, I smell a data set here, right? We have articles, we have manual annotations. Hey, let's do this automatically. Why not? So we crawled all the PDFs, we ran OCR, did a little bit of manual cleaning, and here we had a corpus. The annotations we had to ask for, they were not published automatically with the journal, but the authors were friendly and sent them to us, and the annotations consist of 1 primary frame per text and 0 or up to 2 secondary frames, which we didn't really pay so much attention to so far. So our work really concentrated on just those primary frames, which means for every text we have 1 label, and that's a classical text classification problem then. Document length and class distribution, and here I want to direct your attention to the not very nice distribution, as it happens with many problems. So some frames, I can mark this, are really rare. Security is only 7 texts in the whole corpus, and that will come back to us later on when I talk about methods and results. Yeah, so as I said, it's the perfect setting for a standard supervised text classification scenario. And this work was actually done by 3 of my students, who are acknowledged at the bottom of the page. And we did this little study in 3 phases. The first phase was about finding the best classification method. So we put away 20% of the data as a test set for phase 2. And on 80%, the poor bachelor student Yannick had to run all sorts of experiments with different document representations, pre-processing steps, classification algorithms, and in particular methods for dealing with imbalanced data. And then the best systems emerging from this were then run on the held out test set to give us the final results. And phase 3 then was a follow-up experiment that I will mention soon. So. Yeah, in terms of these standard experiments, not much innovation here, right? The standard pre-processing stuff that you can either do or not do, and Yannick tried all these combinations. Document representations were a bag of words or n-grams or maybe characters. We experimented with different types of embeddings, and in terms of aggregation and weighting, we had different measures. Of course, we tried all sorts of classification algorithms. And we had a few methods for handling these imbalanced data situations. For dimension reduction, SVD, we used SMODE to generate synthetic additional data for the small classes. And ADASM is another method for dealing with this type of situation. So when I show numbers soon, these numbers are really only the very final result of essentially a cross product of all these choices that you have, right? So Yannick really made many, many experiments to figure out what is the best you can do. And the best you can do is these three winning systems. But let's first look at the baseline below. The baseline is just a plain bag of word unigrams. Every term goes into the big bag and nothing happens. No pre-processing, just a plain naive base classifier. The simplest thing you can do. No oversampling strategy at all. And then you get this result, which for an 8-way classification problem is not altogether bad, right? So as we then see, it's not so easy to actually beat this baseline. Okay, so these are the combinations of the different preprocessing classification methods, oversampling methods, and there are the results. Phase 2 then is very short. We just take these three systems and throw them at the unseen test set, and then we have our final numbers. And here they are. Yeah, so the picture is pretty 50-50, right? For the small classes, the results are bad. For the big classes, I mean, what is big? It's still a very small test set. We are still dealing altogether with a small data set. That's problem number 1. Problem number 2, it's very, very unbalanced. Yeah, for some of the bigger classes, results are quite good. And then altogether, we report both the macro average and the weighted macro average, which accounts for the different sizes of the classes. The literature is a bit unclear which one to favor under these circumstances, so we report both. I think the weighted is actually a bit fairer here to consider, but that's to some extent a limit of taste. Okay, so at that point we could stop and say, here are our results, let's try to get this published, and that's it. However, while working on these texts, we also read these texts, many of them at least, and we noticed not a problem, but a feature of the texts, and we asked ourselves, are we actually doing the same thing? What we are interested in and what has been annotated is the framing of climate change. What we are doing is standard text classification, bag of words model, throw the whole text into a big bag and run your classification. And is that actually the best you can do, was our reflective question. And the main observation was that the majority of our texts, yes, it talked about climate change, but actually not all that much. There's very few texts that are really totally about, hey, climate change is there and we have to deal with it in some technological or scientific manner or whatever. Many texts would report about, I don't know, the US federal budget and mention the scientific part, and then in one sentence say, and that also gives the opportunity to look in more detail at climate change. And then it's a climate change text. So we were wondering, are we really solving the wrong problem here by looking at the whole text and trying to classify the framing of climate change? So the idea was to go from sentence to sentence and compute the degree of climate topicality for the sentence, and then run our classifier only on parts of the text, and on the parts that are now yellow, for instance, just to illustrate, okay, to zoom in on the relevant parts of the text. So we rank the sentences for every text in terms of their climaticity or climateness, or the topicality, when we have that. And we take the best classifier that we had just figured out in phase 2 and run it only in the top 1/3, 50%, or 2/3 sentences of the text and see when that improves the results. Now that leaves open the question, what does it mean to rank sentences in terms of climaticity? And again, we experimented with different methods here. So we built a climate vector from a synthetic document using, again, word embeddings, the glove embeddings, and we tried 4 different word lists as synthetic document, artificial document. The first was just the keywords that Hulme et al. Used in the original study, these 8 words, that carbon, pollution, climate, and so on. We compiled a list of keywords from New York Times articles that we had sitting around here. And we went to Wikipedia glossary on climate change, used those terms, that's a longer list, and enriched it from WordNet and got an even longer list. And then you can compare this vector of the artificial document to the sentence vectors in our text that we are interested in. We used 2 different measures for comparing, standard cosine similarity and the word mover's distance, which is a bit more interesting and in many cases more successful It kind of measures how long does it take, not how long, but how long is the path if you go from one word, its vector components, to the others. It's just a nifty way of computing this overall travel distance. And one alternative method is to just train a binary classifier on New York Times texts and use the confidence value as that ranking measure for sentences. Yeah, then a text, sorry for this very awkward visualization, a text turns into these differently colored sentences. Bright red is very climatic, and I think bright blue is maximally non-climatic. And then we rearrange the text, put all the red on top and all the blue onto the bottom, and then we have things that we can actually compare. So we have rerun all texts. Sentence 1 is the most climatic, second climatic, third, and so on, all the way down to the non-climatic sentences. And then the first thing we looked at is how do our different measures for building the climate vector actually compare. To be honest, we had no idea how this performs, right? Build a vector from these keywords, how well do these things really capture what climate change is? So this doesn't tell us anything about the quality of the climate change vector itself, but the relative differences between the two. And the important news then is here, if there's any outliers, then maybe there's something wrong with one of these measures or one of these word lists. And indeed, there is an outlier. The cosine wiki measure or Wikipedia glossary list is obviously problematic. It really has a very bad correlation to all the other measures. And the other wiki variant, the word move distance wiki, is also not correlating very well with everything else. So that was the first step to figure out which list might be not the best one to consider here. So we wondered, what's wrong with Wikipedia? And when you go into these word lists, you find many acronyms, 12 acronyms that probably drive every word embedding approach crazy and do not help this process. And then you can ask your system to please show you the most similar words to that centroid vector that you build from the keyword list. And you get these words, which are interesting, but maybe not the most prototypical climate change words, right? So it's another indication that something is wrong with the Wikipedia list approach. You compare this to the other top 5 words that emerge when you compare to the Holm et al. Centroid vector or to the New York Times centroid vector, and these words look much more promising. That's what you expect when you deal with climate change texts. Besides the values, this just distance, coordinate distance, so these are better than for the Wikipedia. Okay, so the term list really matters for doing this approach. We then computed the overall climaticity or climateness of the text, and we get kind of a normal distribution. That was what we more or less expected. There's a few texts that are really, really about climate change, a few texts that only mention it in one sentence in passing, and the majority is kind of, yeah, it addresses some topic, environmental topic, and climate is also an issue, but not the main topic. Okay, so we have now more information about the text, and we figured, do we get better results? And well, not really. So this is the result we had before, phase 2, Yannick-Bracke's best classifier. The weighted F1 was this value, the macro F1 was this one. And the weighted F1 stays exactly the same with the best keyword list and word mover distance. When we go only for 50% of all the text, half of the most climatic sentences, let's say. But the macro F1 goes up quite a bit. But then again, the macro F1, you see, is really sensitive to the class imbalance problem. Imagine your classifier now all of a sudden gets the security. There's only one security document in the test set. And imagine your classifier now gets it right. It says, yes, I classified correctly. And all of a sudden you have 100% precision and recall for this particular category. And your macro average really replies to that. It shows a good increase. Whereas the weighted average, of course, doesn't really mirror this so sharply, which is the idea of weighting it. And that's why the increase in macro average is not as important as one on this end would have been. Okay, so that was not the most thrilling result, but we decided to explore other methods for looking at framing, because we're still doing standard text classification methodology, right? Bag of word models. And maybe we just have to worry a little bit more about what does it mean if there is a climate change phenomenon and somebody frames it, and we want now to reconstruct the framing that has been chosen for climate change in a text. What does that mean if we want to look for that? Okay, so we then have to figure out what framing actually is, and then go to some social science papers to see what people are doing about it. Their framing is all over the place. With the pandemic, it's the same thing. How do we conceptualize and discuss the pandemic? Twitter is a recent study. Framing messages to deal with the COVID crisis, the role of loss and gain frames and content. So there's many more cases you can find about the role of framing. And as a warning, framing, as you probably know, I guess, is a term used in many different disciplines. And yeah, there is a common denominator. It's usually about structured sets of expectations that people have, and it influences their cognitive processing, in vision, in language processing. In linguistics, the frame word is not only vague, it's also ambiguous, because you have frame semantics in the Fillmorian sense, which is a totally different thing from the frames that I'm talking about here. So that's a problem. And this slide, in fact, is from Charles Wilmore's FrameNet slide set. So we have to be prepared, it's a vague term, and we have to work our way towards a definition, starting with this one that I liked from Stekula and Merkley. This is now not about vision or anything, it's about communication with text. So communicators have a choice of which considerations to emphasize and which to downplay on any given political issue. If you talk about the pandemic, well, you want to emphasize the vaccination campaign. If you are the German health minister, I want to say how great it is working now. You de-emphasize maybe what's going on in the hospitals today. More importantly, they add, and they make such decisions strategically. It's not a random choice. What do I emphasize? What do I downplay? It depends on what do I want to achieve, right? So it's a strategical question. How do I select the things, the aspects that I emphasize? And in the social sciences, a definition that is very popular is coming from Entman from the 1990s, who said that in communication, frames can do 4 different things. They can define problems, determining what some causal agent is doing, what are the costs and benefits. They can diagnose causes of the problems and identify the forces that are creating the problem. They can make moral judgments, evaluating what these agents are doing, or suggest remedies. So that's 4 different, very generic functions that frames can achieve when they are applied to a communication task. And I want to take a minute to take you back to the 1980s. Maybe you have heard of these studies from Tversky and Kahneman. I'm now going into cognitive psychology for just a minute, because I find these old studies still very intriguing in a way. More or less the same story, one version, other version. The left version says you want to go to a theater play and admission is $10. You go to the theater and you figure out you have your purse and all is fine, but one $10 bill is missing, unfortunately. So people are being asked, would you still pay $10 for a ticket for the play and proceed as you had planned? The question is, how many people will respond yes to this? I will tell you in a minute. The other version is slightly different. So you have a different group of informants and you tell them, you bought the ticket already, you go to the theater and you discover, oh, my ticket is gone. The seat wasn't marked, your ticket is lost, but you can buy a new one. So you have to pay another $10. So question now, would you pay $10 for your second ticket that you can actually use? And the question is, how many people will reply yes to that? So observe that the net outcome is exactly the same. You lose $10, right? Here you have lost a $10 bill and you use another $10 bill to buy your ticket. Here you have lost the ticket, which is worth $10, but you have to buy it anew. Your dear ticket is lost already. So it's a slightly different emotional cognitive situation. And indeed, you get a very interesting difference. 88% of informants have no problem just buying the ticket, because losing a $10 bill is, well, it happens, right? But if my ticket was gone, oh my goodness, I was so endeared to my ticket, it's gone. Do I buy a new one? Only 46%. And that's really interesting, I think, because it tells something about how, yeah, different framings of a situation, different emphasis distributions, let's say, can create different responses in people. The last definition I want to discuss is from a very recent EMNLP paper, actually, so from our field. And I found it interesting because they they emphasize the well-known point of priming. So framing for Roy and Goldwasser is a nuanced political strategy used to bias the discussion on an issue towards a specific stance by emphasizing specific aspects that prime the reader to accept that stance. And this linkage to the notion of priming is interesting, because that's, of course, also coming from cognitive psychology and psycholinguistics. And here's one other older experiment now for priming. Same story on the left and on the right. The black is exactly the same. The red and the green are different. So we have this peninsula with a shoreline and a road, and Bob is driving along the road. And on the left-hand side, this shoreline is rugged. The road has hairpin turns. There's jagged cliffs. In the other version, the shoreline is smooth and flat. The road is straight and level, and Bob drives past many white sandy beaches. The last sentence for both stories is the same question that Matlock asked: how long does it take for people to process these two sentences, the identical sentence in both cases? In the classroom, I now, of course, ask everybody to raise a hand and get a vote. We don't have the right technology for that here. And it turns out that the green version text makes you process this sentence considerably faster, statistically significantly faster than here. And that's cool, isn't it? Because, you know, roads and things are rugged, and there's turns and curves and jagged cliffs and stuff. And for this road, you need to really apparently imagine what this road is doing along the peninsula. And it takes more time in the case, as opposed to when everything's smooth, flat, straight, and level. Okay, what does that mean for our framing topic? Well, as you can imagine, the same thing can happen in political discourse, right? We are being primed by a story, and then the continuation of the story is being perceived in different ways. And that's the point that Roy and Goldwasser in their paper are making. By framing, in their case, the immigration issue, using, for instance, a morality frame or a security frame, the reader is primed to accept the liberal or the conservative outcome of a short text, respectively. And this goes an important step further. You take the same frame, the economic frame, but use it in different ways, and you can still prime your readers into different directions to accept a liberal or conservative perspective overall. So these innocent semantic priming effects, which have consequences for reading times in story comprehension, also have their relevance in, in political communication and in opinionated text. And here's an example from that paper. So this is the immigration issue. It's an economic frame in both cases. The left-oriented text says employees, many of whom are undocumented immigrants from Mexico, Ecuador, and elsewhere, toil 7 days a week for less than minimum wage with no overtime pay. So these people are really not well off. On the right-hand side, the text says, mass immigration has come at the expense of America's working and middle class, which suffered from poor job growth, stagnant wages, and increased public costs. So you start off with mass immigration, and then you have all these negative terms, right? Suffer, poor job growth, stagnant, increased costs. So it's a very different framing strategy. Okay. So priming has its role also in argumentation, and that should suffice for introducing the notion for my purposes here. And I want to look at just a few papers, maybe 3.5 from the social sciences that now go to climate change. The first is a meta-study done by Nick Bardulovic, with whom I cooperate in Australia. He's a communication scientist, and they ran a meta-study figuring out how prominent is this problem in the social sciences at large. So being communication scientists, ways of building a corpus is very important. And most of this journal paper is justifying how did we run our search and which sources did we consider and so on and so forth. So we can really assume that this is a relatively representative corpus for framing of climate change in the social science research literature. And yes, it does go up, and they differentiate between different types of studies, which we don't need to go into. The more interesting part of their study is they actually then look at the frames that are being used there in these studies, and they compile this overall list of frames, which is now a new sense of frame. It's not like in Entman where you might do exactly these things, because in fact, Modulovic and friends, they relate these topic frame categories then now to the Entman frame categories, which means diagnose causes, suggest remedies, make moral judgments, and define problems. And so this is interesting because you can see that scientific is the most prominent frame being used, whereas self-efficacy, which means does the individual person out there in the world have to reply or respond to climate change by changing their behavior, that doesn't play such a big role in the social science literature, and so on. So that's just as background. The topic is kind of important in the social sciences, and I want to look at 3 papers in a little more detail. The first is on blog discourse. So we have a large set of blog posts coming from 3,000 different bloggers. And the bloggers, not the individual posts, but the blogs as such, have been labeled as acceptor for climate change, or skeptical, people who don't really believe in climate change, or neutral. So that for every blog post, it is known it was written by somebody who believes in climate change or not, or we don't know. They use 2 different word lists, positive virtue words and negative vice words from an old lexicon, and they used 133 climate change topic terms from some earlier research. And what they want to know is, are some of these topics framed more positively or negatively by the skeptical versus the acceptor bloggers, and how do these communities then use different terms in framing their topics? And to study that, they found all the sentences containing one of these 133 topic terms, and then for every topic term computed this particular score, which we don't need to get into in detail. Basically measures to what extent a word is used to indicate goodness in the acceptor side as opposed to the skeptical side. So a high or low score indicates that the topical term is framed as more what they call morally good in either the acceptor or the skeptical community. So they rank all these terms, and they find that on the left-hand side, these terms are most positively framed, they are morally good in the acceptor community, whereas these are framed good in the skeptical community. And then they spend a few pages on interpreting this. Okay, so that's interesting, but the point I want to emphasize here is that the next step they do is to say, okay, these automatic results are nice, but from a social science perspective, not necessarily the final word. And many of the studies I looked at actually take then the step to take the human into the loop. And these people built an interesting tool for the human analyst who can now go through the corpus, click to see the positive, negative contexts, and then in the end, see which virtue and vice words are most important, and go to the actual snippets in the blogs to conduct additional analysis. So that's very common in social science, that the automatic tools are seen as a tool to support the human analyst, but not necessarily to replace them. Next study is also on big data, but now from Twitter. And it's a different notion of framing that is being used here. That's why I chose this one. So we have almost 6 million tweets now from 2 years for English-speaking countries. And they were found just by looking for climate change and global warming, which is a simple way to do it. Maybe not in terms of recall, it's not perfect, probably not, but that was not their point here. And they checked the most retweeted tweets because they figured those are most liked and most important, and selected frame-specific keywords for their purposes, so they could then measure how many tweets attended to the particular frames. And their frames are a very different thing now. They wanted to know specifically, is climate change a risk or not at all? Is climate change real? Is it a hoax that the scientific claim of the risk? Well, is that a lie or not? So that's the hoax question that's being discussed in the skeptical or denial community of climate change. Is the CC, the climate change risk caused by human activity, is the cause frame that you can discuss, and what are potential consequences of the risk? It is the impact frame. Finally, what do we do about it? How to handle the risk? Do we take some action in one particular way or another? And then these lists that are now used as search terms come from these 500 most retweeted tweets, right? So search keywords are essentially derived from these important tweets. And then it's, yeah, these slightly more extensive search queries they use to figure out how many tweets belong to these frames, which again is a very coarse way of doing things. If I want to know whether the hoax is discussed, then yeah, okay, that's the first thing I can do, look for these keywords in particular. But I'm sure there's many other ways to actually do it. Nonetheless, they get some results to compare the countries. But again, that's not the point here. If you're interested, then you can look at the paper. My point here is to just illustrate the methods and the kind of questions that are being asked. Last study of this type is more recent, from 2019. These people looked at US print media, New York Times, Washington Post, Associated Press Agency, and the Wall Street Journal. And now framing again is something different, and I had warned you that it's a very fuzzy issue. They want to know whether climate change is framed in terms of economic costs and benefits, in terms of appealing to conservative and free market values, or the uncertainties surrounding climate change. Does it exist or not? Is it anthropogenic or not? And the risk of taking action or not. So that's now the framing set that's being used here. I selected this study because it's one of the few that actually uses supervised classification in the social sciences in an established journal paper there. So in order to find their articles, they in fact used supervised machine learning. They manually coded 2000, oh, I'm sorry, some subset was manually coded, and then machine learning was used to find the rest of the articles. And then the frame coding was also done manually only on a subcorpus, 2000 texts, and then a classifier was trained, very similar to what I explained in my first half of the talk, using a bag-of-words model for the remaining 12,000 texts. So that's an application, supervised classification, for finding these 4 frames. And again, the results, then they compare how do these different newspapers deal with risk, ideology, economic matters, and uncertainty, which we don't have to look at here. Right, so in the social sciences, this whole business is prominent. That's message number 1. Number 2 is it's pretty much unclear what framing actually is there. Almost everybody refers to these Entman categories that I mentioned at the beginning: diagnose causes, make remedies, and so on. But few people actually use them. There's 2 or 3 studies I saw that actually use the Entman categories for annotation. Apart from that, everybody does their own thing. Yeah, so let's look at some NLP work. In NLP, framing is not a big thing. I found in our community and the standard outlets these publications, and I'm sure I missed some, but probably not totally many, because of course the recent papers also discuss the related work, blah, blah, blah. So I think this is reasonably complete, in fact. The early work by Boltowicz and Snyder didn't mention the term framing, but actually did framing under the disguise of argument mining. And everybody else says we are doing framing. And I'm not going to walk you through all these studies now. Instead, I mentioned 4 clusters that I found where these studies can be put into in terms of how do they understand and approach framing? What is framing? The first cluster says, okay, we have generic frames. We have a list of topic-independent generic frames, such as those found by here, for instance. Now that's climate change specific. Sorry, I wanted. No, it's also climate change specific. Ah, the list is gone. I'm sorry. So imagine a list of frames that is not specific to climate change. Now I recall where it is. Sorry, it is here. This comes also from a social science paper, in fact, and these people say, if you study framing, then these are the things that are relevant. Economy, capacities and resources for dealing with things, morality, fairness and equality, constitutionality, jurisprudence, and so on and so forth. So that's an approach to framing that says, I don't want a new framing theory for every domain, be it immigration or same-sex marriage or climate change. I want a general framework. So that's an interesting idea. And it was used in this line of research because actually the same team of people who produced this taxonomy then also built a corpus, the so-called media frames corpus, 16,000 news articles from US news media. And they labeled them manually with these 15 frames and then did some classification experiments on text level, very similar to what I presented in the first part. And other work then built on that and did things in technically more advanced ways or in a multilingual way by mapping the whole thing to Russian, which I found a really interesting approach. Okay, this is top down in the sense that this frame list was conceived by introspection of social scientists who figured, yes, these are categories that are out there in the world and in people's minds. Alternatively, you can use generic frames, but generate them bottom up. You say, we go to the data and let's see what we find there in terms of generic frames. And Zur et al. Is one example. They looked at political statements from the 2 parties in the US. They used automatic topic modeling, which is totally unsupervised, and then generalized these very unruly topics as they are. They come out of such a system. They manually generalized them into clusters, which are called frames, and you end up with similar things to what we just saw, health, economy, and so forth, but derived in a bottom-up fashion from the data. So that's the main idea of the second cluster. And Menini et al. Is a similar study on US party manifestos, where the macro domains were already given. They were similar to these things, but only 7 of them. And in this bottom-up inductive way, they generalized phrases to topics, which are then sub-topics, let's say, of these macro domains, and they called them frames. Jur et al. Does a very similar thing. They derive their frames bottom up, and then they have this interesting idea. They find statements on certain topics. Then they have one clustering method to find out if I have a statement, half a sentence, 1 sentence maybe, what are the words that characterize the topic? Immigration, same-sex marriage, climate change. And then they remove these words to get rid of the topic. And then they say, okay, the rest must be the framing, right? And in that way, they get to the framing language, which is to some extent then topic agnostic. Yeah, and they grouped in the second clustering approach then the remainder of the statements when the topic words are going into these frames. And Roy and Goldwasser, whom we have seen before with the definition, they used the media frames corpus, this one, the annotated 16,000 news articles, and generated subframes in an unsupervised manner. That's why I placed them here. So they basically made a more fine-grained version of this 15 category taxonomy by Potsdam et al. Third cluster is very small, just one paper, and we've seen it already. And these people work on the interface between social science and NLP. They publish in both camps. That's why they get mentioned also here. We have top-down frames, but now domain-specific. We have a climate change-specific frame list. And that's very similar to what Hulm et al. In the study did that I presented in the beginning. Yeah, so these people start with 133 climate change subtopic terms they get from earlier research, which I actually mentioned earlier. They have these virtue and vice words, and then determine the stances that authors take on these subtopics. And then they call this moral evaluation, which is maybe a strong word for what is going on there, but it's about sentiment analysis, essentially about lexicon-based sentiment analysis. Fourth cluster says there must be some generic frame language, and let's uncover it. And a good example for that is Baumer et al. 15. They use political news articles, and they use crowdsourcing, which is a bold move, to find framing words and phrases. And they use the categories from Entman and rephrase these Entman categories as instructions for the crowd annotators. Hey, you annotator, frames help organize facts and information. They help define what counts as a problem, what constitutes a solution to a problem, and so forth. So annotators were supposed to grasp the idea of these four components. And Baumer et al. Then built an automatic classifier and figured out what features are actually helpful in finding this frame language. So that's an interesting approach. I think to a good extent, yeah, this crowdsourcing task actually worked more than I had expected, actually. Yeah, classification, of course, is difficult, as you can imagine, but I found the crowdsourcing annotation actually the most important contribution. Yeah, and a very recent paper, which is technically up to date to current technology and is really interesting, is about political news articles. They extract opinion statements from these news articles automatically by doing dependency parsing and then a rule-based approach to find communication verbs and find sources of opinions and content of opinions. And they have a very smallish framing question. They want to figure out, do people frame stuff in climate change actually in a self-affirming way or an opponent-doubting way? That means that when I quote somebody else, do I say there is a trustworthy source, or do I say, well, there is somebody said something, but I don't believe that? And just one example is this minimal pair down here. If you use the word claim, then, well, it's not clear that you agree or are supposed to agree with that. If I say that scientists claim that the 2-degree target of the Paris Agreement is not enough, then I'm not necessarily trying to convince you that's the case. I just say scientists claim that various scientists found has this air that these people know what they are doing, and you might be inclined to believe that. So Luo et al. Looked at this particular sub-problem of how sources of opinions are being framed as trustworthy or not, and that makes this paper very interesting. Right, and that's my wrap up of what happened in NLP about framing. And we're now almost done with the complete thing, so we can wrap up with a little summary. I talked about our own case study in the beginning, a bag of words-based text classification of the frames used in the Nature and Science corpus, and told you the story of how we went from one experiment to the next. I pointed out that yes, framing is a vague notion adopted in many disciplines, so it's not surprising that it is a vague notion. In the social science, I showed you some examples of research questions that people are interested in. And I mentioned these 4 clusters where the NLP work, to my mind, seems to fall into when it comes to framing. Okay, I owe you kind of a definition for my own purposes. So how do I see framing? Well, pretty much in the way that Hulm et al. No, that's not quite true. It's a mix of Hulm et al. And one later study. So what do I think? I think it's more or less a four-tuple or tuple. We need four things to have framing in the text. We need some issue or event, immigration, climate change, whatever. And this issue has sub-issues or subtopics. In climate change, it's sea level rise, it's rainforest, deforestation, and so on and so forth. And you better have a stance toward either the main issue or one of these sub-issues. If you don't have a stance, then there's no need to do framing, right? If you just describe what's going on, then okay, you're describing, but you're not strategically using language in order to influence how your readers should respond to your text. If you have a stance, then you might want to try to do that. So far, we're doing sentiment or stance analysis, in fact, right? It's kind of aspect-based sentiment or stance analysis. And then the frames come in, and these can be either general, as in some of the work, or domain-specific, as in other work. And you need a list of frames that is used to communicate the stance on the sub-issue. And those are the components of the four-tuple. This is not totally new, of course. It's just one way of writing things up in a, let's say, less vague way, even though, of course, we need to know what is an issue, what isn't an issue, what are sub-issues, what are not, and so on. In terms of technical approach, is framing like named entity recognition or, I don't know, question answering a well-defined computational linguistics NLP task? No, I don't think it is. It inherits from all sorts of things, from text classification. It inherits from, this is my personal taxonomy of subjectivity analysis and sentiment and opinion mining, which you can debate if you want. But framing definitely involves stance detection. And as I indicated, it's very similar to aspect-based opinion mining. It has a lot of the literature I mentioned comes from argument mining, where similarity of different arguments is an interesting subproblem. Argument facets is more or less like choice of frame. So there's many points of contact between argument mining and framing. And that means that framing is really all over the place in NLP. These three partial trees are probably still not enough, and there's more, but I think it's the most important parts where framing gets its methods from. Yeah, last slide. So coming back to nature science, right? To close off that very first topic, we haven't thrown away the corpus. As I just indicated, I think stance is important for framing, and that's why we actually are now annotating also stance. I think we cannot do justice to an editorial that talks about climate change and say we have understood the framing without having noticed whether the author sees climate change as a problem or as no problem or as an interesting issue one might spend money on or think about. And we find all three things in our corpus. Remember, the corpus starts 1966. And in 1966, there was not the question, here are climate change believers and here are deniers. It was just, well, does this thing matter that there is some carbon greenhouse level rise somewhere? And that's what we call it. Editors frame it as an interesting issue to look at, or maybe not. And only later on, this point of problem or no problem becomes more prominent in the corpus. So we think this is important. And as I said in phase 3 of our experiment, the whole text is maybe the wrong point to annotate framing. We're doing it now on paragraph level, which I think is necessary to be able to build more realistic, not more realistic, but more precise classifiers. We have slightly modified the frame set, and we're also trying to mark the frame language in line with some of the social science studies that we've seen, which is very difficult. It's hard to get agreement on, and our instructions are not finished yet. And then what we want to do really is to experiment with sentence level frame classification. So figure out whether taking the looking glass at individual sentences can get better results than throwing everything together into one big bin and post hoc reducing it to the most climatic sentences. Yeah, so this is ongoing with my colleagues Nick Badulovich in Canberra and Patrick Santizi in Toulouse. Thank you for listening through this long walk through different branches of.
Oh, thank you, Manfred, for a most interesting